Hi, I'm Jennifer Braggin, Applications Engineering Manager for Entegris. Today I'm going to talk to you about savings that can come in the lithography sector from a resist reduction and monitoring program. This work has been done in conjunction with Spansion. As the cost of lithography increases, engineers are continually looking at ways to reduce cost and improve their processes. In today's processes, resist thickness requirements are much lower than they had been in the past, which means less resist is being used. But realistically, 80% of the resist you deposit on a spinning wafer is spun off the wafer or evaporated. So therefore, it's really important to understand and fine-tune how much resist you're depositing during each process. There are several ways to reduce the cost of resist. One is to change resist, use something that's less expensive. While this seems like an easy opportunity, it's actually often difficult because you need to qualify a new resist. This can take a significant amount of time and effort. Another simple way is to add a pre-wet step. Adding a pre-wet step to your lithography process changes the surface tension on the surface of the wafer and allows you to use less resist to spread across the wafer surface. So this is a very simple technique. However, adding the pre-wet step adds complexity. It adds extra processing time and potential defects in the material that's being used for the pre-wet step. Also, you can fine-tune the hardware. There are several pieces in your track. You can fine-tune each piece to make sure that you are using the least amount of resist necessary for your process. Again, this takes time and qualification, but can ultimately improve your process. While reducing resist based on cost alone is very important, really understanding your process is equally as important. When you reduce your resist consumption, you could be on the borderline of a successful, robust process or a process that fails. What you need to be able to understand is where that borderline is and have a monitoring strategy to catch areas or wafers that might have not been processed fully. In the example you see, that's a wafer that hasn't been coated fully, so the edges have absolutely no resist. This is a failure, and this is the borderline of the process you really need to understand and monitor so you can catch and rework the wafers that don't fit into the normal process spec. So in order to catch these wafers that perhaps weren't processed properly, there are many ways to monitor. The best and most efficient way is to monitor at every point of dispense. Entegris offers the Intelligent Mini to do just that. By utilizing our dispense confirmation software, you're able to detect when a wafer hasn't performed the same as the wafer before that, or any wafer since you characterized the actual dispense. You know real time at the point of dispense that the wafer has failed and can trigger an alarm to stop the wafer from further processing. This is the most efficient way to catch this type of problem, but there are other ways as well. One is a post-coat inspection. This is a more costly option as you need to remove the wafer from the track, have a separate inspection tool to catch the excursion, and then return it to the process. So it's costly in time and also costly in that the inspection tool could introduce defects into this process. The same can be said for a post-exposure inspection, which may also introduce defects and not catch the wafer in time. The worst possible case is catching the defect at a further processing step or at a further monitoring step, like a CD uniformity step or an overlay step. At this point, most likely the wafer has already been processed through RIE or additional steps, and therefore can't be reprocessed and reworked. You have completely scrapped this wafer. As I've just described, one of the worst ways to catch an excursion wafer is at a further processing step. The absolute worst place to catch this type of defect is at wafer final sort, when you're sorting the wafers and ready to send them to a customer and sell the wafers. In Spansion's case, they would routinely find a keyhole defect that you see in the image, and they would find it at wafer final sort and wouldn't be able to find out directly where the defect had been introduced. So they ended up introducing into the lithography sector a defect inspection tool to check every wafer, adding throughput time, and unfortunately it wasn't robust enough to catch this type of defect, leading to several scrapped wafers at wafer final sort. So it really is critical that when you reduce your resist consumption, you also have a monitoring strategy. In Spansion's case, they first undertook the resist consumption reduction. When they first introduced a pre-wet step and changed some of their hardware settings, they were able to reduce the resist consumption by over 66%, which is a significant savings. At that point, Spansion wanted to even further improve their process and make sure they had a robust process. That's when they introduced Entegris' Intelligent Mini, which further reduced their resist consumption by 17%. Not only was the Mini able to produce completely repeatable, uniform results, it was also able to monitor the process, adding even more benefit to utilizing this dispense system. In moving to the Intelligent Mini, Spansion was not only able to detect the excursions at the track, they were able to quickly rework the wafers. As I mentioned, they had historically had an inspection point after every wafer process, and it hadn't necessarily panned out to find these excursion wafers. However, now that they were using dispense confirmation to detect the defects, they were able to remove that inspection completely, saving them process time as well. In addition to now having an every wafer monitoring strategy, Spansion was able to set up statistical process control charts for every dispense point. Because the Intelligent Mini is able to determine if a wafer has had an excursion by providing a value of merit, you could plot that value of merit to an SPC chart, which could be compared to several other tracks. Each track has a minimum of 20 dispense points, so by being able to track one dispense point or all 20 using the same chemical, you can find out where there are differences and where you're having problems, as opposed to relying on a macro inspection to find out after the fact that something has happened. This is really most important if there is a trend. If you're trending and you see wafers beginning to fail, you can act more quickly, as opposed to just having a sample of wafers where you're not necessarily certain if all wafers or some wafers have been affected. By moving to this every wafer monitoring strategy, Spansion was able to reduce their overall scrap based on the keyhole defect. Previously, when they had the macro inspection and didn't use dispense confirmation, they were scrapping 25 wafers per quarter. By utilizing the Intelligent Mini and its dispense confirmation capability, they were able to reduce that to 6 wafers per quarter. So there were several benefits to pursuing this project, first being the cost benefit. Spansion was able to significantly reduce their resist cost per wafer per dispense. Ultimately, let's say, they were able to save approximately 830 milliliters per bottle used. If you assume that there's 1 milliliter of resist used per dispense, that's an additional 830 wafers that could be processed from the same bottle that you've purchased. That's an incredible savings and an incredible productivity improvement as well. This technique also saves significant engineer and technician time. Because dispense confirmation can be plotted to SPC charts, there's no longer a need for the engineer or technician to go to the tool to find out what's gone wrong. They have metrics that they can follow and understand the problem. As I've also already mentioned, Spansion was able to reduce their scrapped wafers per quarter by over 19 wafers. Fewer scrapped wafers means more opportunity to sell good chips, and that's improved profit for Spansion. So in summary, there are several things to think about when reducing your resist consumption: cost, time, and the effort that you want to put in to get the results. There are several factors to consider, like hardware considerations, software considerations, but putting the effort and time in, you can result in significant cost savings. However, by reducing resist consumption alone, you run the risk of having a borderline process. By adding a monitoring strategy, you can find a robust process and catch the excursion wafers and have them reworked, to then benefit by having a more robust process. By utilizing the Intelligent Mini with dispense confirmation, you have an every wafer monitoring strategy, whereby you can point and plot values of merit to an SPC chart to be able to track every wafer. In this particular project with Spansion, they were able to show a return on investment within 2 weeks of using the Intelligent Mini on one dispense point. Thank you very much.